All right, and we are live. Welcome back, everybody, to the fourth week of Tech Bytes and the Python session. We are glad that you guys were able to join us, and sorry for a little bit of delay for today. But as always, we're glad to have you here, and we got a lot in store. Quick introduction, y'all know me from the past 4 weeks. My name is Rayan. I'm a rising senior at James B. Conant High School. I love to code. I've made various apps for the App Store, made a dozen websites, and now I'm looking into transitioning and working in the content creation world. As always, you can find more about me on my website, rayansuzuki.com, and my partner, Andrew.
All right, as always, thanks for the good introduction, Rayan. My name is Andrew Choi. You have, again, like Rayan, seen me for the past couple of weeks. Like I've said, I'm a freshman, soon-to-be freshman at Purdue University. I like coding as well. I know several languages. I like illustrating as a hobby, and you can check out my work at andrewchoi.info.
Ooh. All right, so today's agenda. Last week, we asked you guys to make some quiz games based off of the examples we did together in class, in the virtual class, I guess. And we're going to go over some of the people who shared their examples. Then we're going to answer some questions you guys have from the past couple of weeks on concepts and anything like that. And then we're going to discuss some terminology and discuss what loops are. And then we're going to combine all the concepts that we've learned over the past 4 weeks and make a game which is all-encompassing called a higher or lower game. And we'll discuss more of the details once we get to that part.
All right, so for the quiz games, we do have one submission. This one is by Michiel. Sorry if I pronounced your name wrong. This is very simply, hold on, Redeemus has a question right here. The website kept saying not responding. Could you clarify what website?
Which website are you talking about, Redeemo? Were you sure to click Python 3? For me, the website was just working a couple minutes ago. We can look into more of that. Andrew, you can continue.
All right, so as I was saying, the code here is really based on what we did last week, in that it is having a sort of score counter, having a bunch of if statements, really illustrating the techniques that we learned last time, especially with this question structure. For the actual questions themselves, we have something akin to mythology questions. We have a historical question in the form of Buzz Aldrin for the second person to land on the moon. And we also have even some other things like card games, being using those if-else statements, using both Pokemon and Magic the Gathering. So thank you, Michiel, for that submission.
Yeah, for sure. You know, we next time, hopefully, when we ask, we get some more submissions. But Michiel, great job taking that initiative and coming out. Good job. All right. So today we want to discuss a concept which we talked about a week or two ago in our JavaScript session. But since this is a bit more introductory course, we want to talk about a new term, that being loops. Now, loops are exactly like what they sound. They're like a set of instructions which the computer keeps on following until a certain condition is met. Now, Andrew and I always provide an analogy to what are computer science terms in real life. And loops are essentially, think about them like something like tasks or chores, which you keep on doing until your mom says, hey, you can play video games, or until you can do a certain action. Likewise, loops in computer science are either they keep on running until a certain condition has been specified, or they keep on running a certain number of times which you've specified. All in all, it's that idea that these loops will keep on running and executing code until a certain condition is met. And until that condition is not met, whatever code is in the middle or inside of the loop that code will keep on running, and we'll get into more of that and see how it actually works in a little bit.
I think you should probably explain this one, Ryan. I'll explain like the next slide.
Yep. So Sadan is saying that our voice is cutting off. Maybe
All
that
right.
connection issue, Sadan.
Is it just both of us? As in, are we both coming in very like cut offy, or?
It also depends if you are on a phone or laptop.
No, Rayon. Okay, so it's just for Rayon then.
Rhythm says she can hear us both clear. I'll try to go a bit slower, I guess, but nothing I can do from my end,
Yeah.
unfortunately. Unless you want to try leaving and entering again, but yeah. All right. So this is from the JavaScript session, which we talked about a couple weeks ago, and this is how we're able to actually see. It's a prime example of what loops are. We can see here that this piece of code telling the computer to move forward will keep on executing until the condition of the character reaching the final destination has been met. So reading this out loud in English is saying, hey, repeat the code inside this chain essentially until my character has reached the end. And that code being keep on moving forward. And we're able to see that being related to some JavaScript, and we'll relate it to some Python in a little bit.
All right, so before we go on to the actual coding, I think we should probably talk about some common uses of loops whenever you're programming, and why you might use a loop instead of, say, just coding it yourself and trying to do each iteration of the loop yourself. So let's actually see some examples. Performing repetitive tasks. So imagine you are using some type of app that some type of user interface. So for instance, when you have a piece of code that has a GUI or user interface, the code itself has to continually listen for events like user input. What that means is that if a button is waiting to be pressed, it will have a loop which will constantly check, is this button being pressed? And for this loop, it might say terminate when you press it. So it's very good for waiting on certain events because you have to keep checking things in a repetitive manner. Labeling is incorrect. You're supposed to say 1, 2, 3, but going through a list, imagine if you had a series of numbers and I gave it to you. It could be something like 3, 5, 7, 9, 2, 1, 4, 3. In this case, I might give you a question of whether each number in that list is even. How would you figure it out? You would use a loop. And in that case, the condition there would be if you found a number in that list that was not even, then that would break the loop. Otherwise, it would go through each number in a very sequential order. So if I give you like the first number as 7, I check the 7, then I go to the next number I give you, for instance, 3. And I would keep checking it. All right, so next, this is an exhaustive list, but the third common method is doing massive calculations. So whenever you're coding, coding is very often used for data science and things like data analysis and like solving like big computational questions. And I think a very pure example of that is how they found the minimum amount of moves to solve a Rubik's Cube. So that happens to be 20. Now, a Rubik's Cube, I think everybody's familiar with that. It's the 3 by 3 by 3 colored like cube that you like do those Rubik's Cube solve videos. In order to actually find that the minimum amount of moves was 20, they had to effectively check every Rubik's Cube combination. Now, to give you some perspective, there are 43 quintillion possible Rubik's Cube combinations. So you can imagine how frustratingly long it would be to actually code that many checks on your own for the Rubik's Cube. So instead of doing that, computer scientists use something called a loop, which we've been learning, to iterate through each possible combination and check the minimum amount of moves. So this is a very clear example how you would use loops to perform a calculation.
Yep. Thank you, Andrew. Looks like we got something in the chat. Oh, they can hear. Okay, they can hear us. Great. Okay, thanks, Andrew, for providing some more examples of loops. And since we have looks like the same amount of people who have been participating in both classes, we've been getting a lot of practice in with these loops, and we'll get into some more. Speaking of some more, let's combine all the concepts which we have been talking about over the past couple of weeks to make a higher or lower game and actually apply all those concepts. Now, last week, we applied the concepts of variables, functions, and logic statements, if-else statements, into making a quiz game. And we saw how we could use if-else statements to determine if an answer to a question was correct. And we made multiple questions, and that was last week's activity. For this week's activity, we're going to be using variables still if-else statements, functions, but this time we're going to be adding on loops to make a higher or lower game. The basic idea is as follows. The computer will beforehand generate a random number, and then it's going to be our turn to keep on, the user's turn essentially, to keep on entering a number until they guess the correct number. And as I previously mentioned, we're going to be using those concepts like functions, and more importantly, today we're going to be applying loops and seeing what games we can make out of that. So without any further ado, let's combine everything and make something cool. If everybody can hop on over to our website for Python block coding. At this point, I believe everybody should have it favorited or bookmarked, hopefully. I'll leave it on for a couple more seconds if anybody has not. All right, I'm going to open it as well. Oh, it looks like a person needs the eyes on. You need the all right, the link should be in the chat as well, so easy to access. All right, so if everybody's on the website, just please write in the chat, I'm in, so we can get started. All right, so as always, guys, we're going to be using the Python 3 version. Click that, and let's start thinking. And before we actually begin, I just want to put sort of relate how loops work, how we saw it work in JavaScript, and put it in some context in Python. And how about we've showed you guys multiple times using while loops. How about this time we use a for loop and see how a for loop runs. And we'll print a statement, we'll say, and we'll say we'll run it 10 times. And that statement runs and prints 10 times, just showing us that there's different kind of loops we've previously talked about while loops. This is a for loop. Still the same idea that a condition until it is satisfied, the loop will keep running. In this case, the condition is that this loop will run 10 times or whatever you specify right in the range. And using this type of loop called a for loop, like Andrew was describing, we can loop over and get specific data in lists, and it's very useful in some of the cases which Andrew was talking about earlier. So we'll get rid of that, and we'll start thinking about how should we make this higher or lower game. Well, firstly, let's get some basic things set up. We're gonna need the math import, so head on over to import, math, and random. Now you might be like, hey, what are these imports for? Basically, we just need these imports to make sure that we can generate a random number for the computer on the computer side so that we can keep on guessing it. Next, we gotta generate the actual number. So we're gonna need to store that number into a variable. And we know how to make those variables and what they do. So we'll just call this the computer value. And we'll drag it and drop it right here. Now, the computer doesn't generate the number 0. We want a random number. So, Andrew, you want to explain what kind of commands are available?
All right, yeah. So, random numbers. Here we're going to generate an integer. The reason why we are using an integer is because us humans, generally it's easier for us to generate things like 5 or 7 or 1 or 2. Computers don't quite understand it in the same way. Usually when you generate a random number by computer, it'll make some random thing like 5.376532157. Not very useful for what we're trying to do. So for what we're doing, we're just going to generate integer, which is a number without a fraction or some type of decimal. And yeah, I think we just need to input a range.
Yep. So remember, we created the variables by going over to variables, create variable, storing this value, and now we headed over to random, got the random.randint, and dragged it and dropped it in the white space. Now we need that range which Andrew was talking about, defining what numbers can be picked. So how about we do numbers between 0 and 100? Oh, somebody is asking for the blue code. Oh, yeah, okay, so as I was explaining, all we need to do to make the variable is go to variables, create variable, write the variable name in, and then just drag and drop that variable onto the screen. And then we head on over to random.randint, and we drag and drop it into the white space. So, as I was saying that we got to generate a random number on the computer side. And we want that number to be a random number. So let's say we want it to be a random number between 0 and 100. So I would put in 0 and 100. But wait, I would need to put in 0 and 101 as the last number which you specify in a range. It's not inclusive of that number. So this way, we're making sure that our numbers which is being generated is between 0 and 100 actually.
Just as a quick test, we should probably print that out.
All right, everybody's following along? Good? As always, if you have any questions, feel free to leave them in the chat. All right, so we've generated the random value now, which the computer is that's going to be the number we're guessing. How about we print that value and just see if it's working correctly? So how about we go to print, add this variable, and let's see what value the computer generated. Oh, 21. Oh, 40. Notice all these random numbers between 0 and 100, which the computer's generating for us, and we'll eventually guess. So let's get on over to that guessing part. Now, we're going to need to store our value in a variable because we're going to be guessing a number. So let's hop on over and create another variable, and we'll call this our guess. And we'll drag and drop that variable. We'll initialize it right here just with the value of 0. This is basically saying that we're going to start off and our guess is initially going to be 0. Now, we got the basic setup, but we're still not asking the user to input a value, and more importantly, we haven't utilized our loops. So let's use loops now. So let's head on over to our loops and drag and drop a while loop. Now, we want to keep on running the game until the user's guess and the computer's guess don't match. So what we're going to do is we're going to head on over to logic, drag and drop this third to last statement, and we're going to essentially say that until the computer's value does not equal our value, like our guess, we're going to keep on asking the user to input a value. Now, this is a pretty complex if statement for our level, and a while statement for our level, and I want to make sure that everybody understands what's actually happening here. Once again, we're going to keep on running whatever code we put inside of here until the computer's generated value of a random number equals our guess. Okay, looks like everybody is understanding. Cool. All right. Now we actually got to get the user's input. So we'll head on over back to our guess, drag and drop that in here, and we got to ask the user for a number. So, oh yeah, we learned about input statements a couple weeks ago. So we'll use an input statement to ask, what is your guess? Now, remember last week Andrew talked about that this is a string value. This is essentially like a letter of letters. It's a string. It's many letters, right? But a number isn't letters, so we're gonna have to convert this this input from the user into an integer or like a number, right? So we'll head on over to statements, grab the int statement, and we'll drag and drop our input statement into the middle. Now, once again, what this is doing is that it's converting our string into a number. So say we put in the number 20. This is making sure that the number is an integer of 20. Now, we will drag and drop this whole statement onto right here. This way, the computer will keep on asking us to input a guess every time we guess a wrong number or until our values do not match. Now, we've got the while loop set up, but we still gotta make some comparisons to check if the statements match or if our number is too high, our number is too low. So I wanna ask in the chat, can anybody think of what we're gonna use to make those comparisons? Hint, we learned about it in the last 2 weeks ago, and we implemented it last week in our quiz game. Maval, if I'm pronouncing that correctly, Mavalia said a loop. Almost. Remember, a loop is what we're using to keep on asking the user a question. That question being to input a value. Oh, Arav, okay, yeah. So a loop is what we're using right here. Remember, we're saying to the computer that until the values don't match, keep on asking the user for an input. Now we gotta make some comparisons. So we gotta use some logic statements. Anybody remember what we're gonna use? Izan, yep, Izan. Yep, Izan and Arav, good job, yep. That's the answer. We're gonna be using some logic statements, and those being if-else statements. So let's head on over to our logic, drag and drop one of those if statements, and let's think about what we want the code to do. So we have 1 second. All right, yeah. So we have three cases essentially. The first case is that if the computer's value matches the user's input, then we'll just print out, hey, you got the right answer. Otherwise, we got to check if the user's input is too large or greater than the computer's value. Then we print out, hey, too large of a number. Otherwise, we'll say that if the user's value is less than the computer's value, we'll print out, hey, you guessed too low of a number. So let's actually implement that. So I'm just going to copy and paste the statement we have from right here and put it inside the if block. And what we'll do is say if we'll check for the first case, that being if the two values are the same. If the computer value equals our value, then we'll just print out, hey, you got it right, and say correct number. But that's not the only case which can happen. So we're going to use some elifs. Okay, yep, we'll just wait a quick minute. Just to recap what we've been doing, guys, remember, we have three cases which we're testing for. If the numbers match, if our number is too high, or our number is too low. And we gotta check which one of the scenarios occurs, and then print out the corresponding statement. So our first statement was this if statement, checking if the values match. All right, let's move on to our second statement in our second case, that being if our value is too high. So once again, for making life a bit easier, just copy and paste that same statement from right here. But this time, we're checking if our number was greater than. So we'll use the greater than symbol for us. And then we'll print right here that, oops, you guessed too large of a number. Now we got one more case left.
I think we should like fix like the comparisons to avoid Yoda conditioning. Just like a thought.
Okay, sure. So flip it.
Yeah, I think it'll probably like be a little more intuitive if we just say that if it's our guess is lower or greater rather than the answer is lesser or greater.
Yeah, that makes more sense. Yeah. All right. So just to make it a bit more easier, we'll say that if our guess is larger, then we guess too large of a number. Does anybody have any questions up to this point of any of the logic, anything going on right now? It's a lot of code, and we're combining a lot of concepts we've learned. All right, and nobody has any questions, we'll keep on moving on then. If you have any question, guys, always feel free on any part. Now we got one last scenario left. That being if our guess was too little. So a quick, easy command, guys. Just highlight this elif, right click, and just hit duplicate. And we'll drag it and drop it down there. Now our case is going to be using another mathematical symbol, this being if our number is less than the computer value. This time we'll just print out, oops, you guessed too small of a number. Now that was a lot of code. I want to take a quick minute before I run anything to make sure that everybody's on the same page, understanding why we're using these different scenarios and any of the math behind it, anything. Any questions generally you guys have? Izan, Ara, Vredima, Sudan, Sharia, y'all following along correctly? Everything good? All right, I'll take that as a yes. All right, cool. All right, Sudan, thanks for the input.
All
So
right.
we've got our game set up, but we're missing one thing. This is a bit of a technical thing. This being that since we're inside of a while loop, the loop will keep on running. So, Andrew, you want to explain that we're going to need a break statement?
Yeah. So, you mean like, I mean, technically, or it will terminate. Because we do have
Oh,
the while.
it should turn it, yeah.
I
Okay,
think it's better if we instead put a print statement at the end of the if else chain, just to say like try again.
yep. All right, so what Andrew was explaining there, guys, is that if we guess a wrong number, whatever scenario occurs, we'll get that statement, and then the computer will tell us that, hey, please try another number.
And then add like the break. Well, actually, let's run it without the break, and then we'll tell them why you need the break in a bit.
Yeah. All right, once. All right, so let's run this and see if it works. So I believe okay, so we know the number beforehand because I printed it. So the computer generated the value 81. Now let's put in a number, say 10. And what happens? It tells us that, oops, we guessed too small of a number, and please try again. So let's guess how we say a larger number now and guess 90. Now that same if the different if statement runs and tells us that, oops, we guessed a too large of a number. Now let's input a right value, the correct value, and 81, and we got the correct number. This is a syntax. We added it. We should have only added the please try again into the.
I think we can now introduce with the break condition now. Yeah, I think should I just like mention? Should I just like do a quick like tidbit on that?
Sure, yeah, yeah.
Yeah. So as you saw, that last bit, please try again, printed because it was at the end of the loop. Uh, Even though it terminates at the end of the loop, it's still printed like please try again because that's how loops work, the sequential order. In order to fix this, we need to prematurely end the loop. And this is what the break statement is for. We can actually use it in our equal case where it prints the correct number. So, Ryan, could you do that real quick? So now if we go and run it, we will get the correct result.
Yep. So 101, say we guess 50. Oops, too small of a number. Now we guess 101, correct number, and that statement is now printed out again. All right, Shari, I believe it's having a problem saying invalid syntax. Shari, would you like to share your screen to show if we can fix it? Okay, so please try sharing your screen. Let me just give you the right on this to the. All right, try sharing your screen now.
How do I share?
There should be an option at the bottom of the screen saying the green button with an arrow, share screen.
All right, let's see.
Wait, so okay. When I run it, it didn't work, but I can't see the run option right now.
Could you try running it, Sharia?
Yeah, but I can't see the option.
Could it be because you're too zoomed in on the screen?
Okay, there it is.
Oh, it should be the 3 bars, correct?
Yep. So this has happened before. Andrew, you want to tell me what happens?
All right. So, Sharia, are you aware that you must press the 3 bars near the untitled to press the run button? All right.
Yeah,
So,
that now and look.
sorry, what?
So it says nothing. This is what it says.
Oh, okay. Sharia, I know the problem. There's some quotation marks, I believe. So hit exit.
Yeah, I believe you need to
Okay.
give me a sec. I have to look at the print. Okay, so I think you have to use the correct print blocks. So we probably should have mentioned this, that there are actually 2 print blocks, one for the variable and one for the strings, or just what you type on your keyboard. So go into statements.
Okay.
And you will find the one with the hello world.
Yeah.
And you want to use that one instead of the one you used for the oops, you guessed too large of a number.
Oh. Okay.
Do you see the difference?
Well, yeah, I have to put it in here.
Yeah.
All right, that should work. Just know to do that with the second one as well.
Okay. Thank you.
No problem.
All right.
All right. So we're actually like running almost like over an hour.
Yep. So I'm just gonna wrap it up. So guys, I'll be posting this snippet of code to a Google Classroom as always. If you guys lost track or any syntax issues, as always. And I believe that is it. So for next week, we don't have anything much. We just wanted you guys to get a hold of us combining concepts. Feel free to fiddle around, add your own twist to the game, which I'll post in a little bit to the Google Classroom. As always, this session, which is being recorded, will be posted on our YouTube channel, so you can go over in a bit slower manner or however you'd like to check on anything you missed. And starting next week, we'll get into some more terminology, look into some more projects, and learn some more cool things. And thanks for coming to the 4th week, and to all those who have been keeping up for the past 4 weeks. It's been great to have you here. We hope you're having a great time, and yeah, we'll catch you guys next week then. See ya.
Thanks for coming.